This next problem, we're going to be finding the range using the notation given in the domain. So they give you a function, they give you the domain, and we're going to find the range in this, written in the same way the domain is written. I'm also going to do the other ones just as an example, but I'll show the answer and then continue if it was in different types of notation. All right, so having said that, the first thing we have to do is draw our line, right? So let's take a look, because right now we don't know. We have the x's, the domain, we need to figure out the y. So let's draw it. Let's review how to graph a line. So we have this in function notation, f of x, which is a simpler way, simply said, y equals, let me write that over here just as a reference, y equals -1/2 x plus 2. Okay, so where do we start off? Well, this is already in slope-intercept form, so I'm going to go to 2 for the y, right? 0, 2. So this right here is your y-intercept, and it would be 0, 2. Put this in green. And my slope is -1/2. So I would go down 1, 2 to the right. Down 1, 2 to the right. Or up 1, 2 to the left. Because up is positive and 2 to the left would be negative. Up 1, 2 to the left. And this is the line that we get. Okay? Now. All right. Down 1, 2 to the left. All right, cool. So this is the basic line, and now I'm going to put the constraints of, okay, so this is the line. Now, let's apply the domain. They want just the piece that has your x's are -6 and your x is less than 2, x is greater than or equal to -6. So where is my x? Let's see, 1, negative, 1, -2, -3, -4, -5, -6. And 0, 1, 2, 3, 4, 5, 6, 7, and so on. Let me put these here just to build it, right? The way you would. This is your y, this is your x. I went a little backwards, but anyway, so this is your line. We have the y-intercept at 0, 2, and our slope, which means we go down 1, 2 to the right, or if you choose, you can go up 1, 2 to the left. The point is, it still gives you the 1/2. All right, so this is the line. Now let's look at our constraints, and I'm going to use the ruler for this. So my x is less than 2. Here's 2. This side is larger numbers, smaller numbers. It does not include 2. So the line from here forward, from here backwards actually, or towards the left, towards the negative side, I'm going to make it an open circle because it's not underlined. And -6. Okay, here's my -6. And my x, open mouth, greater than or equal to -6. All right, that means my x's are larger than -6, and that's to the right. So, and it includes. So this is the piece that they're looking for, this piece. And we'll have to look at this piece, what happens with the y's. Okay? So here goes. So if my domain is between this, what's going on with my y's? Let me write this in red. Or actually, let me write it in green, since we already did in green. Okay, so my range. Okay. In this piece, what's going on with my y's? Let's take a look. So my y's are what? And I'm going to use this ruler again. Okay, so here, this is my y line, right? So what's going on with my x's? This is how we separated it, like this. And with my y's, let's see. Well, what's the bottom part? We have, what number is that? 1. See, this point is 2, 1, right? 2, What's the y that corresponds? 1. This point, what's y? 1, 2, let me write it. 1, 2, 3, 4, 5. I can keep going. 6, 7. Which is the y that corresponds that's included here? 5. And that point is actually -6, 5. So -6 corresponds with the y portion of that point is 5. So what's the range as an inequality? Okay, so my range is from 1 to 5. What's my smaller number? 1. So I'm going to write that first. 1, y, and this is an inequality, right? 1, y. What's my larger number? 5. Okay, so y has to be, now I'm going to do this, y has to be larger than 1. Remember, it's going up, so y, this is the smallest number. Y has to be bigger than 1. My other y is 5. And y has to be less than 5. Now, the bigger than 1, is 1 included? No, right? It's not included. So I'm not going to put the line underneath. And the 5, is it included? Yes. Okay, and that's our range. We wrote it is an inequality. Now, what if we were to do it in set notation? Well, okay, it's pretty simple. I'm going to do both at the same time. Just as an example, I'll do this one in red and the other one in green so you can see the difference. These squiggly lines, which is kind of funny, it always makes me laugh a little, x such that, and we just copy this. -6 less. Once you have this built, this is already in the bag. You just have to put x and the line and the 2 squiggly lines. X less than 2. Or we can write it this way. X is an element of the reals. Again, just add this little piece, squiggly line, and copy the same thing. Now, let's do the same thing with the y's. Okay, we have the inequality. Let's write it in set notation. Instead of y, we're going to use x, we're going to use y. Y such that 1 less than y less than or equal to 5. Or, squiggly line, y is an element of the reals. Oops, I ate that one. All right. So what's the difference? Well, we just took this and we wrote it here and we put y with this line, y such that this, and we used our to contain it. Right? Y, element of the reals, 1 less than y, y less than or equal to 5. Done. Now, interval notation. Okay, interval makes it look almost like one of these points, but it's not. Okay, so the interval notation, we take the 1, we take the 5. Those are, oops, I'm sorry, I'm in the wrong one. I mean this one. Okay, we take the -6. This is if they had asked us for interval notation. I'm doing extra just so you have the example. Okay. So interval notation, does it include the 2? Okay, does it end? Okay, so we're going to have to, what? Well, this ends here, and this ends here. Now, for the y, we have 1 and 5, and it's also limited to that. It doesn't keep going forward, it's not infinity. So interval notation, there it is. It's closed in 1 and 5. It doesn't extend going forward. You really can't tell if it includes or not. So in this case, it's probably a better idea to use the inequality or the set notation because it really specifies if it's the numbers included or not. But this is the last one, interval notation, which just tells you what space it takes up. And that's it. I hope that helps.